NASA's upcoming project, Artemis II, will take humans back to a part of space we haven't been to in decades.
322 feet tall, 3.5 million pounds. 4 astronauts and no landing plan. It is the first time humans leave Earth orbit since 1972. They'll fly farther from home than anyone alive has ever been. But the most dangerous part of this mission isn't launch. Because after Artemis I returned in 2022, NASA found something they didn't expect. Was this spacecraft actually safe for humans? This is the 2-year journey of how NASA built Artemis II and why every single step had to be perfect. To understand how this rocket is built, we need to go south, all the way to New Orleans. This is where NASA's Michoud assembly facility sits. NASA and Boeing built the Space Launch System core stage here. On this same ground, engineers once built the fuel tanks for Saturn V. Later, they built the orange tanks for the space shuttle. Different eras, same purpose. The core stage is the backbone of the rocket. It stands 212 feet tall. By itself, it is taller than many skyscrapers. It is made of 5 massive structures. A liquid hydrogen tank, which holds super cold fuel. A liquid oxygen tank, which feeds the engine's oxygen to burn that fuel. An intertank that connects the two. A forward skirt at the top, and an engine section at the bottom. Engineers carefully joined the forward assembly to the hydrogen tank. They used exactly 360 bolts. When fully joined, these pieces form most of the rocket's height. But if the core stage is mostly tanks, why is the bottom section the hardest part to build? Because when this rocket launches, all the force, heat, and violence of the liftoff crash into one place. The engine section is the most complicated part of the entire rocket. Inside it are miles of cabling, there are hundreds of sensors, and the 2 massive solid rocket boosters connect to the core stage. When the rocket launches, 4 RS-25 engines ignite. Seconds later, the twin solid boosters light up. Together, they produce 8.8 million pounds of thrust. That is more force than any rocket NASA has ever flown. Super cold liquid hydrogen and liquid oxygen rush down from the tanks above. These propellants are colder than anything found on Earth naturally. But what if even one sensor here lies? Well, the engines that power this rocket are not new, and that is exactly the point. The 4 RS-25 engines at the bottom of the Space Launch System once flew on the space shuttle. For decades, they carried astronauts to orbit and back. They survived extreme heat, vibration, and stress. For Artemis II, these engines were upgraded. But during installation in New Orleans, engineers noticed a problem. One engine showed a leak in its oxygen valve system, and that engine was removed. In its place, another RS-25 was installed. The swap happened years before launch. Building the rocket is only half the challenge. Getting it to the launch site is the other half. In July 2024, the finished core stage left New Orleans. It was carefully shipped to NASA's Kennedy Space Center in Florida. This journey took days. The rocket moved slowly, protected at every step. Other pieces arrived later. Adapters needed to connect the rocket to the spacecraft followed months after. NASA had to pause stacking while engineers investigated problems on Orion, issues with the heat shield. After Artemis I returned from the moon, engineers noticed something strange. The heat shield, designed to burn away safely, didn't behave exactly as predicted. Gas pressure built up inside the shield. Pieces of the char layer broke free. No crew was aboard, but if there had been, NASA wouldn't have accepted the risk, so they stopped. Scheduled lifts, launch dates slipped, because before flying humans, NASA had to prove one thing, that Orion could survive re-entry without hiding a mistake. Once the green light was given, real assembly could begin. That work happens inside the Vehicle Assembly Building, or VAB. It is one of the largest buildings ever constructed. By volume, it can hold 3.5 Empire State Buildings. It is so tall that rockets must be stacked vertically. This is where history lives. Apollo capsules were assembled here. Saturn V rockets stood here. The space shuttle was stacked in the same building. Now, Artemis II joins that list. Stacking began in November 2024. Boosters, core stage, upper stages, Orion, at the very top. Nearly a year later, in October 2025, stacking was complete. For the first time, every major part stood together as one. It finally became a single vehicle, built to carry humans back toward the moon. Love this journey to the moon? Smash that subscribe button now so you don't miss what's coming next. The next thing is to move. NASA calls this moment the rollout. It is when the entire Artemis II rocket leaves the vehicle assembly building and travels to the launch pad. To move the rocket, NASA uses Crawler Transporter 2, the heaviest self-powered vehicle ever built. By itself, it weighs 6.65 million pounds. The rocket and its mobile launcher are heavier than anything the crawler carried before, so NASA upgraded it. Engines were refurbished, brakes were redesigned, new generators and monitoring systems were added, and when everything was combined, the numbers became hard to believe. The rocket, the mobile launcher, and the crawler together weigh about 15 million pounds. That is more than 20 fully loaded passenger airplanes. Preparing for rollout takes days. Engineers lay thick sheets of plywood over the building floor. This protects the concrete from the massive weight. The access platforms around the rocket are pulled back. Cables are disconnected. Then came the doors, the largest doors in the world. It takes 45 minutes for them to fully rise. Only then does the rocket see the outside world. The crawler moves into the vehicle assembly building during the night. Using laser alignment, engineers position it directly under the mobile launcher. The target area is a square about the size of a baseball diamond. The margin for error is measured in fractions of an inch. Once aligned, hydraulic systems begin to lift the crawler. Eventually, the crawler touches the launcher and takes the full weight of the rocket. Only 3 of the crawler's 4 massive diesel engines are turned on. Running fewer engines reduces stress and improves control. When the launch director approves, the rollout begins. Leaving High Bay 3 is the slowest part of the entire journey. The crawler moves at just 0.05 miles per hour. It takes more than 30 minutes for the rocket to fully clear the doors. Outside the building, the crawler pauses again. The crew access arm is rotated, retracted, and secured.
Give it go to proceed with terminal count and launch Artemis 1. Or go for launch. Go for launch.
Then comes the S-turn, a tight curve just outside the building. Only the most experienced drivers are allowed to steer here. 8 drivers are certified to operate the crawler. They work in rotating shifts, 1 hour at a time. After nearly 12 hours, the crawler finally reaches Launchpad 39B, but the hardest part is still waiting. The launch pad is not flat. It rises upward toward the center where the rocket will stand. Beneath it sits a massive flame trench. This deep channel is designed to catch fire, smoke, and exhaust during liftoff, so the rocket does not destroy the pad beneath it. That design creates a serious problem. The rocket cannot tilt. If it does, the stress could damage critical systems. So that's why the crawler uses computer-controlled leveling systems. As it moves up the incline, hydraulic legs constantly adjust height and balance. The rocket stays perfectly upright the entire time. The crawler never stops. Stopping on the slope would be dangerous. For 45 minutes, it climbs upward in one slow, continuous motion. Every adjustment happens automatically, guided by sensors and computers. Once the crawler reaches the top, the final placement begins. The rocket is slowly lowered onto 6 mount mechanisms. Each one is aligned with extreme precision. The core stage now straddles the flame trench below. Technicians connect electrical lines and umbilical cables. Power flows from the pad into the vehicle. Systems checks begin immediately. The rocket is no longer traveling. It's home now. Sean Quinn, the program manager for Exploration Ground Systems, summed it up simply. Everybody who's worked on this program is in effect going to the moon, and this rollout is the most visible first step toward getting to that launch. And finally, launch day is arriving, February 6th, 2026. The rocket would be upright with 4 astronauts strapped in. Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Jeremy Hansen. Together, they will leave Earth orbit for the first time since 1972. When the countdown begins, 7 seconds before liftoff, the RS-25 engines will ignite. At 0, the twin solid rocket boosters would fire. And finally, 8.8 million pounds of force would push Artemis II skyward. In just 2 minutes, the boosters would separate at over Mach 4. The core stage would continue to burn for 8 minutes. propelling Orion into a high elliptical orbit. Once in orbit, the rocket would separate, leaving the crew free to test their spacecraft systems. The interim cryogenic propulsion stage, or ICPS, would fire to raise Orion's perigee. Orion would also test a new optical communications system, sending data back to Earth at incredible speeds. This mission is all about preparation and about milestones. Christina Koch will be the first woman, Victor Glover the first person of color, Jeremy Hansen the first non-American to fly beyond Earth orbit. And all four are the first humans to leave Earth orbit in 44 years. But what do you think? Drop your thoughts in the comments below, and then check out NASA's first medical evacuation from space video. It's a story you don't want to miss.